how 38 ATP is produced from one molecule of glucose, and what's going on in aerobic respiration and what are the changes. If this is the questions of your mind, then this is the solutions. I hope that in my previous class you already saw that I explained the process and steps of aerobic respirations, and we already know that there are 4 steps of aerobic respirations, that is glycolysis, acetyl-CoA formations, Krebs cycle, and electron transport chain or system. And I already said that there are some books where written that there are 3 steps where acetyl-CoA formation is not included as a steps, but in some books there are written like glycolysis, Krebs cycle, and electron transport system are the steps of aerobic respiration. But here I hope that you know this figure already, and we need to explain that how this 38 ATP is produced. To understand that, we need to know first that one molecule of NADH2 is equal to 3 ATP. That is very important. One molecule of NADH2 is equal to 3 ATP. One molecule of FADH2, that is flavin, adenine, dinucleotide, hydrogen, is equal to 2 ATP, and one GTP is equal to 1 ATP, as guanosine triphosphate and adenosine triphosphate are similar. In case of ribose sugar, same. So nitrogen base are same. So in case of NADH2, this is 1 NADH2 equal 3 ATP, 1 FADH2 equal 2 ATP, and 1 GTP is equal 1 ATP. So if you can remember this thing, then you need to understand this one. And if you already understand this, now we need to think that what are the steps and what are the net product of it. So now if you just concentrate on the first step, which is glycolysis, and you know already that in glycolysis process, one molecule of glucose will be break down into 2 pyruvic acid, which is 3 carbon. And in these steps, in this step, if I give you some idea that in this step, this is glycolysis. In glycolysis, what are the substance produced? You know that in glycolysis, there are 4 ATP and 2 NADH2 were produced, right? So you know already that in glycolysis process, one molecule of glucose will be produced 2 molecule of pyruvic acid, and then in the process 4 ATP and 2 NADH2 will be produced and 2 ATP will be lost. So altogether we have the substance produced is 4 ATP and 2 NADH2. So if this is the scenario, NADH2, and from this 4 ATP, 2 ATP is lost. So my net production about ATP is 2 ATP here, 2 ATP, and as 1 NADH2 is equal to 3 ATP, so 2 NADH2 is equal 6 ATP. So we can say that in our first step, 8 ATP is produced. So in glycolysis, the first step of aerobic respiration, 8 ATP will be produced. Number 2, acetyl-CoA formation. In this step, what is going on? If you can remember this thing, that in both cases, pyruvic acid will lose 1 carbon dioxide from each side, and then it will produce 2 carbon pyruvic acetyl-CoA, and then in both cases, 1 NADH2 from this corner, 1 NADH2 will be produced. So altogether 2 carbon dioxide, 2 carbon dioxide and 2 NADH2 will be produced. So as carbon dioxide will be produced, so it is the production of of the aerobic respirations, and you know that when one molecule of glucose is oxidized by 6 molecules of oxygen, then 6 carbon dioxide will be produced. So this is the productions, that 1 carbon dioxide, 2 carbon dioxide, and here there are 4. So altogether 6 carbon dioxide will be produced. So from 2 NADH2 the net production is 6 ATP. Okay, and then the third one, which is the bigger one, Krebs cycles. So in Krebs cycle, what is the production? When acetyl-CoA will enter to Krebs cycle, in both side 3 NADH2, 1 FADH2 and 1 GTP will be produced. So as this production is from two sides, so altogether what will be going on? The going on is 6 NADH2, 2 FADH2 and 2 GTP will be produced. So ultimately, if we see the net production, as we know that 1 NADH2 is equal to 3 ATP, so it will be total 18 ATP. And then 2 FADH2, that is 1 FADH2 is equal to 2 ATP, so 2 FADH2 will be 4 ATP. And in case of GTP, 2 GTP will be 2 ATP. So in case of fourth number of stage, that is electron transport system, in electron transport system, if I say that in ETS, what will be going on? These NADH2, FADH2 and GTP will be transferring into ATP. So in case of ETS, these NADH2, GTP and FADH2 will be transferring into ATP, and then we can understand that the total amount of ATP is here. That is, if we summation that 8, 6, 14, 14 and 18, 22, 32, 32 and 4, 36 and 2, 38. So altogether 38 ATP will be producing, and the amount of energy is 686 kilocalorie. So that is how 38 ATP will be produced. So if you understand the title, that how 38 ATP is produced, so you must know the process of aerobic respirations and the stages of respiration, and in which step how many energy is producing, so that you can make a figure and then you can make a table, so that you can understand that in which level how many ATPs is producing. And in some cases, in an MCQ or multiple choice questions, there might be a question that how many ATP is producing in Krebs cycle, so that an answer would be 24. So altogether 24 ATP is producing in Krebs cycle. So in acetyl-CoA formation, 6 ATP. In case of glycolysis, 8 ATP. So these questions can be available in MCQ, and of course you understand and you can see that what are the exactly processes going on in all steps. So if you understand it well, of course this is appreciable, and of course if you have any recommendations, do let me know. I shall be uploading the next video about anaerobic respirations, and I am hoping your study is going well and you are having good health. So take care, stay well, stay blessed. Bye.